To start off by letting everyone know that I do not take the situation that we are in very lightly, or not lightly at all. A close family member of mine died a decade ago from H1N1, and it could have been avoided if he had been diagnosed earlier. But just the same, something does not sit well with me when I take a look at this data as reported. When I take a look at this data, it just looks off. And since I'm a data junkie and mathematically well equipped to spot bad data, I delved into it further. The curve in late March and early April is much smoother than the data reported earlier. It's as if this data was generated by a different process than the data before it. But suspicion is not proof, so let's apply some mathematical techniques to see what might be going on. Expressing this data as a percent change from the day before allows us to apply some statistical techniques. I also cut off all of the data prior to March 1st, since there wasn't a serious measurement campaign going on prior to that, and since the total number up until that point was still fairly small. Right away we can see that the variability in the data prior to March 22nd is much higher than the data after March 22nd. This is reflective of the smoothness of the curve observed on my first slide. So now we're in a position to quantify just how much smoother the later data is than the earlier data. The data prior to March 22nd has a variance of 2.88% and a standard deviation of 17%. Just to explain to people who haven't encountered these terms before, they are statistical measures of data dispersion. The variance is just the average squared deviation around the average, and the standard deviation is the square root of the variance. In most systems that include regular variation, about 2/3 of the data will be within one standard deviation of the average. So with that out of the way, let's talk about the variation in the later data. I detrended the data so that I could get a better estimate of the variation without the impact of the trend being at play. The variation of the data about its trend is 0.11%, that's the variance, and its standard deviation is 3.3%. Obviously, the later data is much more smooth than the early data. Its variance is a full 26 times lower. But before making any judgments, let's apply a statistical test to see what the likelihood is that this could have just happened randomly. To compare the variances, we use the F-test. In this F-test, the F value is 26.2. We have 20 degrees of freedom in the data prior to March 22nd and 18 afterwards, when I take into account the degrees of freedom chewed up in the detrending process. According to the F table, there is only a 0.0000002% chance that we would have seen a value of F higher than this if the data was generated by the same process. This is an astonishingly low probability. So we are left with only the conclusion that this data shown on the right was not generated in the same manner as the data shown on the left. True, there were some definite differences in social practices taking place after March 22nd, and it is certain that such practices would have impacted the rate at which the cases rise. However, to assume that the changes in practices would result in a 26-fold decrease in day-to-day variation fills me with doubt. Still, admitting this as a small but finite possibility, let's see if we can find other irregularities in the data. And here's one that I can see right away. Human beings are very bad at generating random data on their own, and there are statistical tests that can be conducted to spot human-generated data. One such test is called the up-down test. Look at these 8 points. When viewed about the trend, the data goes up, down, up, down, up, down, up, down. This is highly unusual for data that is generated from something actually measured. Consider the flip of a coin done 8 times. There are 256 distinct patterns of heads and tails that can be generated. But there are only 2 ways that we can get a perfectly alternating pattern. They are heads, tails, heads, tails, heads, tails, heads, tails, and tails, heads, tails, heads, tails, heads, tails, heads. So with only 2 ways for this pattern to come up out of 256, we can calculate the probability of this particular pattern being generated as 0.78%. So it is not a very likely pattern. Sure, if the data were extended over several months, you could see that such a pattern coming up is somewhat likely, but not over such a limited amount of data. So there you have it. Those are my concerns with the data as reported. Am I proposing that we are not in a very serious situation? Not at all. But we all have to do some very serious thinking about the implications of what's going on. My personal concern, aside from everyone's health and well-being, is that at the end of this, we will have a society that will be conditioned to self-impose a quarantine, which in effect renders the right to peaceably assemble clause in the First Amendment impotent without the need to make a single change to the Constitution. The seriousness of this situation cannot be underestimated.